In this video, we're going to review how to resolve a vector into its components. And so we know that we have two vectors here drawn. We have vector A, and vector A has a magnitude of 16 and a direction of 62 degrees. Now, vector A is drawn in standard position. And standard position means that the initial point of the vector is at the origin, because we know 16 at 62 degrees could start anywhere. So for example, I could start it here, and 16 at 62 degrees would be the same vector just starting somewhere else. So that could also be vector A, but that's not in standard position. So standard position means that you start your vector at the origin, and when your vector is drawn in standard position, it's always the same method used to calculate the components of the vectors. Vector B here we have in standard position because it's being measured. The initial point of the vector is at the origin, so that's the standard position. And notice that we have our angle. Our angle is drawn from the 0 degree line. So in math, we have learned that our x-axis is the 0 degree line, and so in math, we always revert back to the standard position being called out from the 0 degree line for your angle. Now, that's not always true in your other classes, and I'll go over that briefly in a few moments. But I just want to review how to resolve, and this is the correct word, resolve a vector into its components. And so basically what that means is we want to get vector A and vector B into their component form. So we want to write these as brackets with an x and a y component. And we want to write B with brackets as an x and a y component. So how do we do that? Well, let's take a look at vector A. And the way that we do it is in vector A, we can look and we can say that we have, this would be our x vector. So that would be the A sub x. And this would be the A sub y. Those are your two vectors in the x and the y direction because the components are in the x and the y direction. Now on vector A, we can see that this makes a basic right triangle. And so we can say that A sub y would have to do with the sine. Sine of 62 would be A sub y over 16. And A sub x would be having to do with the cosine. So cosine of 62 would be A sub x over 16. So I'm going to write those out just so that you can see the whole process. And then we'll come back and give you the general formula. So we can write that the sine of 62 degrees is going to equal A sub y over the magnitude of A, right, which is equal to A sub y over 16. And if we multiply both sides by 16, we get A sub y is equal to 16 times the sine of 62 degrees. And then if we do the cosine of 62, so the cosine of 62 degrees is equal to A sub x over 16. And so A sub x is equal to 16 times the cosine of 62. And we can get those two numbers on the calculator. So if we do those, we get, let's see, 16 times the sine of 62 is 14.13. And 16 times the cosine of 62 is 7.51. And so this vector A could be written in component form as A sub x is 7.51. So that's this vector, 7.51 in the x direction. And A sub y is 14.13. And that's this vector, that's the y direction. Now if we look at this, what that basically means is if I take these formulas, we can say that the A vector is going to equal, and I'm just going to write them in here so you can see. It's going to be 16 times the cosine of 62 degrees, and 16 times the sine of 62 degrees. But there's a general formula that we can write. So since we know that that's the magnitude of the vector, and that's the angle of the vector, any vector can be written in component form as the magnitude of vector v times the cosine of the angle, and the magnitude of vector v times the sine of the angle. That will always work if your vector is drawn in standard position and your angle is given from the 0-degree line. This will always work if your vector is in standard position. So your vector has to be in standard position. That means that the origin of the vector is at the initial point of the vector is at the origin, and the angle has to be in standard position. From our trig knowledge, the angle has to be from the 0-degree x-axis. Okay, so now let's try it for vector b. We're going to use this formula and we're going to do vector b. So we see that vector b was given as 11 at 250. So the components of vector b are going to be 11 times the cosine of 250 and 11 times the sine of 250. And when I do that, I'm going to get my x and my y. Now I'm expecting those should both be negative because I'm in the third quadrant. My bx is I smudged that. My bx is going to be this value, 11 cosine of 250, and my by is going to be 11 sine 250, and I'm expecting that both of those should be negative. And when you do that on your calculator, you get that b is equal to negative 3.76, negative 10.33. And so instead of writing 11 at 250 degrees, we could have wrote in component form negative 3.76, negative 10.33. Now you know that it is far, far easier to add vectors when they're in component form. So this is a very important skill to resolve your vectors into component form. In the next video, I'll go over the different types of angle systems and why in math we always go back to our standard x is 0 degrees position.